All right, let's graph some rational functions. Now, to begin, let's first note that there are several different types of rational functions that you may have seen. For example, 1 over x, 1 over x squared. This video is going to tackle the case where you have an x on the numerator and an x in the denominator. And this is going to change dramatically the way you're going to graph the rational function. So to make things simple, we have these steps here on the right, okay? And we're going to follow each and every one so that we're able to graph the function, but also get all the parts that are going to help us to graph the function as well. So a lot of problems sometimes just ask, find all the intercepts and all the asymptotes. But when it comes to the graphing, we don't really make that connection without having to go through the whole process. So let's go ahead and do that. So starting with step 1, it says factor the numerator and denominator. Okay, what that means is there might be something you may need to factor. So without practice, it's going to be hard to figure out whether or not it's fully factored. So at the top, there's nothing to factor out. Okay. With a little bit of experience, you'll realize that the bottom can be factored out. In fact, the bottom is a difference of squares. And so as we may have covered in class, this becomes x minus 2, and this is x plus 2. Now we fully have satisfied number 1. We factor the numerator and the denominator. In this case, it was only the denominator that needed to be factored. Number 2 is write in lowest terms. In other words, cancel factors in the numerator and the denominator. Okay. So in this particular case, there's no x plus 1 that can be canceled at the top and the bottom. So number 2 is actually done. The next step, it's asking for us to find the intercepts, both y and x, if possible. Now, this is going to be the beginning of getting the features that are going to be actually graphed on this graph on the left. And so everything is set for you to just read in case you forget. And it tells you what you need to do to get something. So for the y-intercept, it tells you explicitly plug in 0 into your function, if possible. And then for the x-intercept, set the numerator equal to 0. So anytime you ask yourself, well, I don't know how to find the x-intercept, no matter how crazy your rational function is, this process should not change for the most part, okay? So to find the y-intercept, I'm literally going to plug in 0. So I'm going to take, in this case, I'll start doing some work here because finding the y-intercept isn't that much work. So 0 plus 1, and then 0 squared minus 4. So all I did was plug in 0, okay? 0 plus 1 is 1, and then that becomes negative 1/4 essentially. So when I plugged in 0, and this is for future reference, right? So the y-intercept itself, it's just negative 1/4, but you could always write it as a coordinate for future reference, okay? So if you're working on Pearson, MyLab Math, is it MyLab Math? Yeah. Please make sure that you're reading the fine print that tells you whether the empty box should be just an integer or y equals something for an intercept. So otherwise, it's gonna think you're entering the wrong item that it's asking you for. Okay, so we're done. We're done with y-intercept, right? So now for x-intercept, all that says is to set the numerator equal to 0. So x plus 1 equals 0. Therefore, x is equal to negative 1. So that's your intercept. But again, if you have the second, write it as a coordinate as well, because once we get to graphing, you're going to need to graph it anyways. So now we're actually fully done with 3. Just to switch ink here, let's go to green. All right, moving on to 4. So finding the asymptotes, okay? This is very crucial because it's an important part of how it sort of dictates how the graph is going to come out. So Vertical asymptotes is set the denominator equal to 0 and then solve for the x values, right? So I'm going to start down here. So vertical asymptotes, and then we're going to just follow the instructions. Set the denominator to equal to 0. So there's two ways of doing it. You could set this denominator equal to 0 or this one. But because this is already in factored form, to me it's going to be the easiest. So x minus 2, x plus 2 equals 0. And that leads to x minus 2 equals 0. Or x plus 2 equals 0. Okay. So then your actual vertical asymptote is literally x equals 2, comma, negative 2. It's always best practice to write the the lesser number first. So we should have written out negative 2 first, but as long as you can recognize the order, it's fine. Okay. Now we've done the vertical asymptote. The horizontal asymptote is actually the easiest once you get the gist of it. So I'm going to write down horizontal asymptote, but that really is based off your ability to read the fraction and be able to extract the degree of the top and the degree of the bottom, okay? If you're having trouble with what is a degree, please look for another video and just type in Google, finding a degree of a polynomial and then also of rational functions. That kind of helps out a little bit. But just to keep things simple here, find the largest exponent on top and the largest exponent on bottom and the denominator and just compare them. So in this particular case, when it's in factor form, it's hard for you to see that, right? Like you have to be capable of counting your x's. So the numerator has 1, so that's degree 1. This bottom one has degree 2 because there's 2 x's. It's a little easier to see it when it's in standard form, meaning not factored. Right here, this is a degree of 1 because the largest x has a power of 1, and this is degree 2 because the largest power is 2. So, taking into consideration our case, we fall under this category here. So, because the degree of the numerator was 1 and the degree of the denominator was 2, therefore you have a horizontal asymptote at y equals 0. This is a very popular outcome here, and it happens a lot. The second most popular one is when the degrees on top and bottom match. That means you're going to have a horizontal asymptote at the ratio. So again, the ratio is actually easier to see here. So if these two were exponent of 2, let's just say you take your ratios, the ratio here is 1 over 1. So really you have a horizontal asymptote at y equals 1. Let's just change it up, right? If this was 3 squared and this is, let's say that's 2, then you see the exponents match, therefore you take the ratio and that is your asymptote. So you would have an asymptote at y equals 3 over 2 here. And just to touch base on that, see, in factored form, it would be hard to see the leading coefficients like you can in standard form. So sometimes actually it's not wise to take the ratio from this. It's best to sometimes go to the initial form if it was standard form and take it from that, okay? So before we start to deviate too much, again, the degree of the top was less than the bottom. So then the horizontal asymptote is just at y equals 0. Okay, it's that simple. Now we're getting closer to graphing. We're already at number 5, right? I hope if this is too much, please stop the video, go back, go forward, speed up, whatever it is you need. Lastly, we're gonna find where the graph intersects the horizontal asymptote, and this might seem a little funky on what does that mean, but again, I'll touch base on that when we graph it, but for now, just take it at face value and then just go with it, right? The purpose of this first run is to write the instructions, read the instructions and then follow them to the T. So set the function equal to the horizontal asymptote y and solve for x, okay? And then write as a coordinate. So, I'm going to just do that. So take my function. In this case, it was of notation Rx. So for where the graph intersects, sorry for the sloppy writing, the horizontal asymptote. So this is taking your function and setting it equal to your horizontal asymptote. That's this right here, okay? In this case, it just happens to be 0. So that gets converted to x plus 1 over x squared minus 4. Now, again, you could use either factored form or this form. It doesn't matter. Okay, whatever works for you. Again, quick shortcut here. Anytime you're having to solve for x and you have a denominator, you're going to need to multiply the denominator to the other side. And the other part is anytime you have a 0 on the other side, it actually cancels out because 0 times anything is just 0. So ultimately, you end up with x plus 1 equals 0. So if you simplify that, that becomes x minus 1 equals, sorry. If you simplify that, that's just x equals negative 1. But again, it said write it as a coordinate. So then that means that we have negative 1 comma 0. So this is the coordinate that I was talking about. But once again, right now, piecing everything together might be a little bit problematic because you might not be able to like see it all. Like you can't see the big picture. But we're going to start graphing it right now and you'll see it kind of come together. So with that being said, to start graphing everything, just start putting all these details on the graph like from beginning to end, right? So for example, all right, so we have the intercepts, right, that we found here. So in the initial part right here, we found the x-intercepts and the y-intercept. Well, drop those in the graph. So we have 0, negative 1, 4 right here, like right there. We also have x-intercept, that was negative 1 comma 0 right there, okay? And then we move on to the asymptotes. We had two asymptotes, one at negative 2. So this is where you draw the dashed line. One at 2, okay? And then we have a horizontal asymptote at y equals 0. Now, be careful with this. You don't want to make, a bunch of lines everywhere. So I drew these dashed lines, but like you don't want to get overly exaggerated with drawing them because then your graph is going to get so crazy. You don't know what's where. We're almost there. So the last part is graphing this wherever the line or graph is going to cross the horizontal asymptote. But if you notice, it's actually the same thing as your x-intercept. So it's right here, right? It's this little one right here. Now, this is where I'm briefly going to just stop real quick and just say why it crosses. Ultimately, the ones you really need to worry about is really just the vertical asymptotes. Why? Because you shouldn't have any values on the vertical asymptotes because in a nutshell, if you did, you're going to make the denominator 0 if you actually have, some sort of point on a vertical asymptote. So that's why you can never truly cross the horizontal asymptote. But if you notice, the horizontal, did I say horizontal? So the vertical asymptotes has everything to do with the denominator, so you don't want zeros there. However, the horizontal asymptote does not have anything to do with the denominator. So in a nutshell, you can kind of cross the horizontal asymptote. It's fine because it won't make you have a denominator that is 0 because that's not possible, right? So with that being said, how do we tell how the graph goes, right? How do we know how this graph is actually done? This is where it just goes to being able to do a number line down here, right? So really you have everything on the graph you need. All you're missing is the sketching of the actual function so that you know where things are crossing. This actually helps a little bit because normally when it's something like this, it usually crosses like that, but we'll find out right now for certain and then we'll graph it. But the best thing to do is essentially create an an x-axis essentially. So down here we're going to draw this little x-axis, and then what you want to put is whatever's on your x-axis right now. So what we have are our vertical asymptotes, right? So we had one at -2. We also have one at 2. And then what we're really doing is a mini graph, okay? And this is going to help you actually graph the real actual function above. And then the other one you want to write as well is this intersection with the horizontal asymptote, or also known as the x-intercept here. So that value was -1. So I'm going to draw this over here. I'm going to make it actually not be so close because we're going to create little intervals right now. And that's -1. So now what you want to do in order to graph this, now once again, this -1 was an actual point, okay? But we're still going to use it to create an interval. And the -2 and 2 were vertical asymptotes. So what you want to do here is pick test points to the left and to the right of each asymptote, essentially. So this one is going to be test point of -3. This one, unfortunately, is going to be a decimal of -1.5, right? That's the only thing that's really nice in between -1 and -2. Here we'll have, well, we're actually in a bad spot here too. It's got to be 1.5. Actually, no, I lied. Let's take that back. Between -1 and 2, you could use a test point of 0. That's the better one. And then to the right of 2, it's 3. Okay? So all these test points are things that you're going to plug into the function to see what your output is going to be. So follow along here. Please do not deviate from this too much, because then you're going to have to restart the video here. So -3. So we're trying to find out if it's going to come out to be positive or negative. So I'm not going to do the work because as I'm running out of space, I don't want to get it so that it's so crowded here with the work. So I'm going to plug in my first test point of -3, and I'm going to do it to this function here, okay? So I want to see if it's going to come out positive. So -3 plus 1, okay? -3 plus 1 is going to be negative, so that equals negative, and that's going to be divided by whatever we have at the bottom. So -3 squared, okay, that's 9. Okay, that's 9. And then minus the 4 that's right next to it, that's equal to 5. But 5, all we care about is the fact that it's positive. So if you look here, we have negative divided by positive. And ultimately, when we plugged in -3, our result is essentially negative, because negative divided by positive is negative. So we ended up with an outcome of, let me use this color, negative here. So we want to know that. So by the way, because it's negative here, our graph is going to be like that here. That's the whole purpose of this, okay? If it was positive, it actually would have been up here. So this is the purpose of what we're doing. I'm going to do this test point, and out of experience, I'm going to guess this one. So I'm going to test the point 0, and testing the point 0, okay, 0 plus 1, and then 0 squared minus 4. So 0 plus 1 is 1, which is positive, divided by 0 squared minus 4, which is negative. So we end up with positive at the top, but negative at the bottom. So in all, it's a negative, okay? So when we plugged in 0, we ended up with a negative number. So that's going to be negative here. From experience, I could tell that this should be positive. Therefore, my graph would have been going like this. This is where you're going to be careful. Let me see if I could get a nice color here. So it would start like, oh, I put positive in the bottom. My bad. I should have put it up here. Now, just to touch base on that one more time. If I get positive, I put it on top, and if I get negative, and I put it on bottom. That also helps me graph. So my graph would have been arrow and then crossing the x-axis, and then since this is negative, it would be going down here. So to the right of this -1 point, it was negative, but to the left, it was positive, right? So that's what that means. So on the last test point, I'm almost certain, I'm just going to take a nice little gamble here. I'm thinking that it's going to be here, okay? But let's just double check. Test point 3. So if I go up here, 3 plus 1, okay, that's equal to +4, so that's positive, divided by 3 squared minus 4, but it's 9 minus 4, so that's 5, which is also positive. Positive divided by positive is positive, so in fact, it was on top, right here. So then this is your graph. So by doing it the way we did it right now, right, and please go back and review this part if you really didn't get it the first time, all right? It's super crucial. And all I'm going to do is go to the top and literally just copy what I just did, right? I worked hard the first time just so that I could go up here and truly be able to sketch the graph. So that was this. This started positive, but according to our graph, it was negative after our -1, okay? And then it was positive on this side. So the positive and negative really pertain to the outputs. So my output of the graph to the left of -2 was negative. My outputs between -2 and -1 were positive, okay? So negative to the left of -2, positive between -2 and -1, and then between -1 and 2, it's negative, right? -1 and -2, sorry, -1 and 2 is negative, and then lastly, after 2, it was positive. And that's what it is. So I hope this information helped. I'm going to make a second video, and the second video is going to pertain to using this problem and this structure to solve a problem on Pearson, because that's a different beast, right? The way Pearson wants this type of question answered is really lengthy, and they use a lot of terms that can throw you off. So please, again, rewatch every single part of this video and make sure you're understanding each component, from getting the intercepts to vertical asymptotes to being able to graph if necessary.